Okay, so this video, really, we're just looking at a recap of the transformations that we need to know, because we're going to look at a mixture of all the transformations in the next video. So this video is really important. So just to recap, and we'll go through each of them one by one. Right, there are 4 types of transformation that you need to know at the grade 4 level. The first being a translation, which you'll see in a second. We've then got reflections, enlargements, and rotations. So we'll go through each of these one by one. Okay, just to quickly recap what all of these mean again. This is really important for the next video. So let's begin with translations. So here we go. We've got a coordinate axis with a shape on that grid. Okay, a translation transform the position of a shape. Okay, the shape always stays the same. That's really important. So the shape, the size of it isn't going to change. It's not going to rotate or anything. It's literally just moving the shape. Okay, and we use something called a vector to describe the change. Okay, where if we have the vector like here, we've got 3 and 1. That 3 describes a horizontal movement, so to the left and to the right. If it is positive, we go to the right, and if it is negative, to the left. And then similarly, write your number on the bottom. There is a 1, plus 1. Okay, positive is going upwards, negative is going downwards. Okay, it works in a similar way to a coordinate. Okay, so when we translate the shape by the vector 3, 1, we move it 3 across. So we choose a point, okay, and you literally count 3 squares, so to the right, so 1, 2, 3, okay, and there we go. You've got your new point over here. So let's check it. Right, we go 3 across, 1, 2, 3, and then we've got to go 1 up. So we then move it 1 up, and there we go. Okay, and what you've got to do here is you can check with a point to make sure it's correct. So choose the corresponding points. So let's go for the top point here and the top point up here. Right, it should go 3 across, 1, 2, 3, 1 up. Yes, it does, and that will be the case for all of those points. Okay, so that is a translation. Let's look at another one. So this one is moving 4 across and 3 up. So we're going 4 across and then 3 up, like so. Okay, and then we can double check. We can choose a point, okay, and that's count. So let's go and choose this point again and this point up here. So they're corresponding the same points, and they should be going 4 across. So 1, 2, 3, 4, and then 3 up. 1, 2, 3. Good. And that'll be the same for any of the points. So this one here will be going 1, 2, 3, 4 across. 1, 2, 3 up. Okay, and then one more, which includes negative signs. So this one, right, because this time we've got -3 and -4, well, if you've got a negative horizontal, we're going to the left. That's negative, that's positive direction. And then again with the vertical, right, -4, plus is up, minus is down. So we're literally going 3 to the left and then down by 4. 3 to the left and down by 4. And let's check with a different point. So let's go for this point this time, and this point down here, and it should be going -3 across and 4 down. So 1, 2, 3, and then 4 down, 1, 2, 3, 4. Okay, so yeah, all good. I've translated the shape by that vector. Good. Okay, now on to reflection. So we've done translations, reflection, which is in the name, right, reflecting a bit like, along a mirror line. So the question here is, right, reflect shape A, so this shape, in the line x is equal to 3. Okay, well that line is really important, x equals to 3. This is your x-axis, okay, the point 3 is there. So you've got to go and draw in a vertical line at that point. Okay, that is the point x equals to 3. And then we're reflecting along that mirror line. So you choose a point, like they've gone for the bottom left one here. You count to your mirror line, which is 1 square, which means you've got to go 1 square across from your mirror line. So there we go. You then take another point. So we go from now this point this time, and we count 1, 2, 3, 4 squares. So then you go 4 squares again from your mirror line, and there we go. Okay. We then choose another point. So there, 1 square across again, and then your final point, 4 squares across, so 4 squares, and there we go. And we go and draw in our shape. Okay, and I've just called it A dash. It just means that is your new reflected shape. Okay, so we can see it looks right, doesn't it? There's your mirror line, x equals to 3. I've reflected it along that line. Good. Nice question here, right? I want to reflect shape D, this time in the line y is equal to x. We need to know what this line looks like. That is your line that goes like this. Okay, literally we're going 1 square across, 1 up, across 1, up 1, across 1, up 1. And that is the line y is equal to x, and that's a really important one to know. When you're reflecting diagonally, a similar idea, but this time you choose a point and you count diagonally from that point. So we go diagonally by 1, 2 squares. So then we go diagonally up by 1, 2 squares. Okay, to give us our new point, which is going to be there. And that's good. choose another point, another vertice on your shape. Let's go for this one down here. Okay, and we're counting 1, 2, 3, 4 squares diagonally, which means again we're going from the mirror line 1, 2, 3, 4 squares again. Okay, to give us our new point, which is up here. Last but not least, we've got our final vertice, which is only half a square to your mirror line, so you count half a square diagonally up, and there we go. There is your final point. You join it all up, and it should look like it's been reflected in that line, and it does. Okay, that looks pretty good. So we've got our new shape, d dash, reflected along the line, y is equal to x. Good, now on to enlargements, which is a nice one. So this one here, we've got enlarge. Let's highlight the keywords here. We've got enlarge shape A by scale factor of 2 from the center of enlargement 1, 4. So some really key parts here, right? We've got enlarge means you're getting either bigger or it could mean getting smaller, okay, which we'll look at in a second, hopefully. Scale factor 2 means that you need to times or double the length of the shape by 2. And the center of enlargement is from the point 1, 4. So let's go and plot this coordinate, which is 1 across and 4 up, which is here. And then what we need to do is we count from this center of enlargement. So this point here is the center of enlargement. And we go to a vertice of our shape. So we've gone from the center to this point here, which is 3 across. And because the scale factor is 2, we need to go now and double that length of 3 back from the center of enlargement. So it was 3 originally. We then go back, scale factor 2, we double that 3 to give us 6. So that point now goes to over there. Okay, we then choose another point. So they've gone for now this vertice down here. So that's 5 squares across. Scale factor of 2 means you need to double that length of 5 to make it 10. And again, you go from the center of enlargement. So we now count 10 across, and there we go. Okay, last but not least, we want to go to this vertice up here, which is now sort of looking at 2 directions. So 2 up and then 5 across. Or you could have gone 5 across and 2 up. It will make no difference. And then you've got to double these lengths here. So now it's going to be 4 up and 10 across. So it's going to be 4 up and 10 across. And there we go. There's your final point. And then we can join it all together and we get our new shape, which I've called B in this case here. Okay. And then this is a really important point, right? You can always check you've enlarged your shape correctly by joining together the corresponding vertices. So like, for example, this point up here and this point, we can draw a line going through it. There we go. And similarly, like if I go back again, this point here and this point here, okay, and this point here and this point here, if we connect them up with lines, like I've done here, they should all meet up. So these black lines should meet up back at the center of enlargement, which they do. Okay, so I know that I've enlarged it correctly. Okay, so that's good. So I've doubled the length. Scale factor 2 means I've doubled the lengths of the shape here. This has gone from 2 squares to 4 squares. This has gone from 2 squares to 4 squares, so on and so forth. I've literally doubled all of my lengths. Okay, good. This one, I want to enlarge shape A by a scale factor of a half. So this time, right, I'm kind of times everything by a half, or I'm dividing by 2, okay, with my lengths from a center of enlargement 10, 2. So begin by plotting that center of enlargement. Right, it sounds a bit confusing because it says center of enlargement. It just means that coordinate, which is 10 across and 2 up, which is going to be there. And again, you choose a vertice. So they've gone for this one first, and that is 4 up and 4 to the left. Because your scale factor is now a half, you need to divide everything by 2. So it's going to be now 2 up and 2 across. There we go. Good. We then choose another vertice. So let's go for this one over here. Okay, and they've gone 8 across and 4 up. We're now dividing it by 2 with our scale factor, so it's going to be 4 across and 2 up. There we go. And then the final point, we want to be going up to here, and that's going to be 10 up and 8 across. Okay, and we are again dividing it by 2, scale factor a half, so it's going to be 5 up and 4 across, and there we go. Okay, so I've plotted all of my points, and then I join them up together to get my new shape. And again, we can check we've done it correctly by matching up and drawing lines through the corresponding vertices. Again, I mean like here, that's my top vertice there, top vertice here. Should really use a different color. It's a bit confusing with the red on red. Let's go blue. So let's go from up here to here. And then this point should connect through this point, and this one should connect through this point. So there we go. Okay, and they all go through the center of enlargement, so I know I've done it correct. Okay, and now on to rotations, which is going to involve some tracing paper, which I've got on the screen, which is quite nice. So this one here, some keywords, right? Rotating literally means that we are rotating our shape, like we're turning it around. So we need to rotate this by 180 degrees. Okay, so let's make sure that we know what the turns are. So let's get this in red. So if we just draw like a bit of a helper guide here, right? If this is going to be 0 up here, right? A 90-degree turn, so 90 degrees is a quarter turn. That's 90 degrees. 180 degrees is a half turn. Okay, 270 is like a 3/4 turn, and then 0 or back to sort of 360 is going to be a full turn. But usually you just need either 90 or 180. Okay, so here they say rotate shape A 180 degrees. So I want to go and do a half turn about the point 21. Label your new shape A dash. So we've got some pointers here to help us go through this, but what we need to do here is, well, first of all, let's put in the coordinate 21, which they've already done for us. So this is the point by which we are rotating the shape, which is really important. We place the tracing paper. So place the tracing paper over the top of the shape, which I've done, and mark in the 4 vertices of this shape, which they've already done. So they've literally marked on the 4 points here. You then, and this is a really important point, you've got to put your pen or your pencil on the point by which you are rotating, which is the point 21. So this point over here. Okay, so put your pencil on there. And then you press hard with your pencil on that point, and then you move the tracing paper 180 degrees, which is a half turn. And because it's a half turn, it doesn't matter which way you go, it will be the same thing. And there we go. Okay, so I've rotated that shape, and then you've got to go and mark in and this is the tricky bit really in real life, because you've got to sort of quickly remember what the points are and plot it quite quickly. Okay, if we do that, there we go. And there's my new shape, A dash. So I've rotated the shape by a half turn, 180 degrees, about the point 21, which is this point here, which is good. Okay, that is done. And my new shape I've called A dash. Good. Let's look at one more. This time I want to rotate shape B 90 degrees, rotate 90 degrees clockwise about the point 01. So this time the direction does matter. So clockwise, just to remind us, is the way the clock goes, which is this way. So the point 01, let's go and plot that point there, which is there. And tracing paper over the top and kind of jot down the 4 corners. You then place your pencil on the rotation point, which is 01, and you're moving it 90 degrees, which is a quarter turn, 90 clockwise, so in this direction here. So we do that, there we go, and then we take our paper off and we mark in the points, and we get our new shape, which is B dash. And that is our final one, I believe, for this video. Okay, hopefully that was useful. That was a quick run through all of the transformations again. Thank you for watching, and hopefully that was useful. Brilliant.